growth and decay. Growth and decay. Yeah. Give you the homework now. You've done this before. Yeah, that's like that. All right, growth and decay. So let me show you what the function looks like, the parent function anyway. I've got these values here, a times b raised to the x. I could add or subtract values here, but this is what it looks like. Now the a, the b, the h, and the k all have numbers in place of them. The x, of course, stays, so it looks a little different than what you're used to. The variable this time is up in the exponent. Them. So a couple of things before I start. The b, which is the base, tells us whether we're talking about growth or decay. If b is bigger than 1, and by the way, b is never going to be negative. If it's negative in front, then that means a is negative. And we'll do several examples like that where I can show you what I'm talking about. But if b is bigger than 1, then it is a growth. And if b is less than 1, but remember I can't be negative. So if I'm talking about less than 1 and not negative, what am I talking about? Fraction. Then it is decay. So, for example, I think I'm going to put 4 up here. And we're just going to say growth or decay on these. Looking at the first equation, is that growth or is it decay? Why? Oh, you better just do your test, buddy. Is it growth or decay? It's growth. Why is it growth? The base is bigger than 1. How about this one? Growth or decay? Decay. Why? It's a fraction less than 1, right? How about this one? Growth. Remember, if there's a negative in front, what this means is A is -1, B is still 3, which means it's growth because 3 is bigger than 1. How about the last one? Growth or decay? Why is it growth? The fraction itself is bigger than 1. 7 over 2 is 3.5. What's A in that last equation? -1. What's B? 7 over 2. See how we're doing that? Y'all are going to be fine. There you are. All right, so let me show you what they look like before we actually graph them. Oh my gosh, these are easy. No, we don't have subtractor. Be excited. This is fun. A growth. Notice I have this dashed line. This dashed line is what I call an asymptote. A-S-Y-M-P-T-O-T. So let me tell you what an asymptote is before I finish graphing this. An asymptote is an invisible boundary on the graph. invisible, I call it a boundary. The graph can never touch. But although it can never touch, it always gets closer and closer and closer and closer and closer. I always describe that as if you put the number and you divide it by 2, that's dividing the result by 2. Zero will be your adding. I started out with 4 and I divided by 2. You got what? 2. Divided by 2 again. Divided by 2 again. Half. Divided by 2 again. Or a 4. Divided by 2 again. 8. Divided by 2 again. Divided by 2. We could go on forever and ever, but we're never actually going to. Right? 0 would be the adding. Does that make sense? So you can hug it, but it never actually touches. So for a growth graph, here's my asymptote, and what it does, it hugs from the left, and then it starts increasing really fast. And so that's what a growth looks like. Now, remember that number in front, that A, whenever I start talking about my function transformations, that A in front can flip my graph over if it's negative. So in the case of a negative A, this is still a growth. This is when the A in front is negative. Okay, but that's still growth. Decay does just the opposite in that I have my asymptote. It starts out really, really big, and then it drops down fast, and it hugs this asymptote as it goes. That's where it keeps dividing by 0. So it's steady decreasing, but it'll never decrease so much that it crosses that asymptote. Does that make sense? And then, of course, if A is negative, that could flip over. Tell me something. I got it? All right, let's graph them. I told you in the beginning that the function looks like the base or the B controls whether I am growth or decay. The A will, of course, be my shrink or stretch up, down, like my reflection. But whenever I graph this, the graph is much easier than just thinking through that way. Here's what I'm going to do. The first thing I'm going to do to graph, and I think I'll just show you the steps to graphing, and then we'll jump over to actually graph. The first thing I'm going to do is graph the asymptote. And the asymptote, it's always horizontal, and it always happens at y equals k. Whatever that k value is there, that is my asymptote. Okay, so if nothing's there, where's the asymptote? 0. That's exactly right. All right, step 2. Y'all ready for it? Step 2, we're going to plot the point H, A plus K. And when you do this, be careful, make sure that the H is the opposite sign, the K is the same sign. Yeah. And then the last thing that I'm going to do is I'm going to find an easy point. And to do that, I'm just going to choose an X. Choose an X beside that H from step 2. And this will make more sense, I think, whenever we actually go through and do it. All right. I need to get my crap together. Growth or decay? Rat, do your test. Armando, growth or decay? Growth. Bless you. Somebody tell me. Somebody. What's A? Bless you. What is it? What? There's no A, which means A is what? 1. What is B? And then, of course, my HK. Tell me, where is my asymptote? Where is it? Okay, let's go back. -7. Thank you, Kayla. The number on the very end is my asymptote always and forever. So I'm going to go down to -7. 1, 2, 3, 4, 5, 6, 7. And I'm going to do an asymptote. Step 2. Okay. Plot the point H, A plus K. What does that point look like? What's H? +2. And now A plus K. -6. Don't forget to add that A to it. So I've got -2, -6. Yes? Everybody okay with that? Yes. All right. Now, I need another point, and this is where you can do whatever you want to do. But because growth and decay get really big really fast or really small really fast, it's best if you just stay right beside this point. So give me an X that's right beside this point. 1, or I'd probably go to the right, but you don't have to. I'd probably go 3. But if you went 1, you're not wrong. Okay. As long as you go 1 to the right, you'll end up with an exponent of 1 every time. It just happens that way. Okay. So where are you confused? Okay, so A, we said A is 1 and K is -7. So 1 plus -7 would give me -6. If I choose 3, how do I find the y value that goes with 3? Plug it in. So I get 3 to the 3 minus 2 minus 7. What's 3 minus 2? Okay. 3 to the first is 3 minus 7 is -4. So what are the coordinates of this point? 3, -4. All you need is 2 points. 1, 2, 3, 4. Can you see the way that it's increasing really fast and the direction in which it's going to hug the asymptote based on those 2 points? I hope you can. It's going to scream up that way real fast, and this is the way that it's going to come around and hug that asymptote. Everybody okay? Thank you. Thank you. Thank you. How about the range? No. -7 up to. No, because you can't actually be the asymptote. You can get really, really close, remember. I can keep cutting in half, but I'll never actually be there. For the domain, yes. For the range, it's always going to be either the asymptote to infinity or negative infinity to the asymptote. All right, how about in behavior? As x approaches infinity, it goes to infinity. That one's easy, right? The other end is the true definition of an asymptote. So as x approaches negative infinity, what is the graph doing? What is f of x approaching? -7. I'm approaching, never becoming, but approaching and getting closer and closer to -7. Do y'all see why that is? I'm hugging that line. The further I get left, the closer I get to -7. Never actually will be -7, but I'm approaching it. How about a y-intercept? How could you find a y-intercept on that? No, let's don't do y-intercept. Well, how do you find a y-intercept? Algebraically. What happens every time you cross the y-axis? Let me give you a hint. There you go. X is 0. X is 0 every time. So to find the y-intercept, I just put a 0 in for x. So go back to that equation and go, okay, well then the y-intercept would be 3 to the 0 minus 2 minus 7. That what happens with a negative exponent? Close to the second, which is 1/9. And if you want to use your calculator, you can. If you're good with fractions, this is 63/9. So it's -62 over 9. What? Oh, y'all don't need another example? 11. But the first 5 are not graphing. The first. There's 11. You know what? For 4 and 5, just keep the same directions as 1 through 3. You don't have to describe the transformation. All right, I'll do 6. 7 or 8? Tell me where the asymptote is on this one. -3. It's always the number on the end. Don't let that throw you. It's super easy. The asymptote, and that's the blank right there at the bottom on the right. The asymptote is y, and make sure you put y equals, because that's what tells you that it's a horizontal line. Y equals -3. So there's your asymptote. Yeah. Oh, no, yeah. Where did they go? Because I had enough. Oh, Elizabeth's done before you. Oh, that's not, no, wait, that's not them. I'm sorry. All right. All right, here's my asymptote, yes? Say yes, because that's right. Is it growth or decay? How do you know? A fraction less than 1. That's exactly right. All right, give me a point on my graph, any point on my graph, preferably the way I showed you to do it. Oh my gosh. -4h, a plus k. -2. Don't forget to add that a. Even if a is not there, it looks like it's not here, it still is, and it's still 1. And so don't forget to add that 1 to it whenever you find your, this is your h, a plus k. Yeah. No, this, so a is 1, b is 1/2, h is -4, and k is -3. Where are you confused? H, a plus k. All right, I need another x. What x should I pick? -3, because -3 is 1 to the right of that one, yes? Okay. So now what do we do to find the y that goes with it? We plug it in. That's always how we find the corresponding y. So I've got 1/2. This is raised to the -3 plus 4 minus 3. 1/2. This is just going to be a exponent of 1. What's a half minus 3? -2.5 or -2.5 or -5/2, however you want to write it. So I go 1, 2, 3 over to the left and down 1, 2.5. So yes, see how it hugs there? As long as you've got 2 points, you can tell the way that it shoots up and you can tell the way it hugs the asymptote. Does that look like a decay graph? Yes, as you move to the right, it gets really small really fast, or it hugs that asymptote really fast. What is the domain here? Oh, y'all got that. That's your favorite, mine too. How about the range? Close, bottoms up. So what's the lowest it goes first? -3 up to infinity. Always a parentheses on these because you can never touch the asymptote. Okay? Always parentheses, yep. How about the end behavior? As x approaches, no, -3. And how about as x approaches negative infinity? Infinity. How about the y-intercept? Plug 0 in, so you get 1/2 to the 0 plus 4 minus 3. 2, 4, 8, 1 over 16. I don't know what that comes out to be. Negative 47 over 16. Or if you could do the decimal equivalent on your calculator, it doesn't matter. To know where it's crossing, negative 47 over 16. That's all I got for you. I'll let you work. I'll let you cook.